Stretches and shrinks.
Yay.
Okay, so a horizontal stretch or shrink is where our graph is going to be stretched.
Or shrinked.
Or shrunk, yes, horizontally.
Like that bus on Harry Potter.
Like the bus on Harry Potter. A vertical stretch or shrink is where what we have is going to be stretched vertically or shrunk vertically. Now, at some point, you may be like, aren't those like kind of the same things?
Yes,
like,
they are.
Like sometimes when we horizontally stretch,
We vertically shrink.
you could talk about the vertical shrink, but our equation is telling us a specific way of doing it,
Right.
so that we know what the factor is we're stretching by.
Right.
Because just because you vertically shrink, you may want to know, I'm vertically shrinking by a half. Who would want to know that?
Mathematicians.
And
wanna know
architects and all of them people
Right.
would want to know that for sure. And so for horizontal stretches or shrinks,
Thank you, Ms. Teal.
that's the inside of our function. So that's
Right.
the super secret opposite society.
Right, which is now the super secret reciprocal society. So,
SSRS? That doesn't stand for anything.
Let's keep it opposite, I
Okay.
think. But remember, when we say opposite here,
We're talking
we mean
about reciprocal now. Okay, we're not
All right.
changing the sign. We're
Yeah.
talking about reciprocating. Okay, so whatever's inside of our function, the first thing you need to do is flip it. Okay, so if you have 1/2, flip it and make it 2.
2/1.
If you have like 3, you flip it and make it
1/3.
1/3. And then that
What if
is
you got
gonna
like
help
3/3 or no? What if you have 2/3? What if you have 2/3?
Then when you flip it, that's 3/2.
There you go. See, it's
Okay.
not hard.
So when you flip it, that's going to tell you the stretch or shrink. Because
Right.
if I flip it and get 2, that's a horizontal stretch. But
Right.
if I flip it and get 1/2,
That's a shrink.
that's a shrink.
Right.
Okay. If you look at it pre-flip, then it's going to be confusing. Look at it after you
Yeah.
flip it, and then figure
Right,
out if it's
right.
a stretch or a shrink.
For sure.
Vertical stretches or shrinks, they're my
Those
favorites.
are easiest. Those are the easiest ones to see in the whole world.
Yeah, they're on the outside. They're literally multiplying your y values
Right.
by whatever number
Right.
it is.
So if I take 2 and multiply 2 by something like, I don't know, 3,
Yes, that's 6.
that's 6. That's
Yeah.
3 times more than 2, which was where I started.
Yeah.
That's up.
Yeah, so
Okay.
so whatever this number is on the outside will actually be either your stretch or your shrink. So if it's a 5 on the outside, you're stretching by 5.
Right.
If it's a 1/2 on the outside, you're shrinking by a half.
Right.
All right, let's do this example.
Okay, let's do it.
Okay, this is worded kind of weirdly.
Uh-oh.
Okay, so it's a good thing we're doing this together. Let C1 be the curve defined by...
y1 equals f of x, which equals x cubed minus 16x. Notice
Okay.
that here we're saying very concretely y
Is
equals f of x,
Yeah,
which
they're the same.
is equal to x cubed minus 16x. So this is a little bit of vocabulary for you,
Right.
or maybe some
Something like that.
recognition.
Okay, and notice this is not exactly a parent function.
No, it's
that we've
been
got.
manipulated
It's
a
been
slight
manipulated, But we
skosh.
can still do this. But we wouldn't necessarily ask you to graph this.
No.
Straight off the bat. So
Right.
find the following equations. C2 is a vertical stretch of C1 by a factor of 3.
Okay, so we're
So-
going to look at the vertical stretch, which is the bottom situation here.
Right? We're doing 3 times our
f
function.
of x. Okay, that means 3 times everything that f of x equals.
Okay, 3 times everything that f of x equals. Well, f of x equals x cubed minus 16x.
Yes, and now you just distribute and multiply.
Right, and we'll call this C2
yeah,
for funsies because
Okay.
they called it C2, and so that's
3x cubed minus 48
Nice math.
every now and
With
then.
an X.
Mhm.
Okay, that is our graph stretch with
There you go.
a vertical stretch of 3.
See, that wasn't hard.
That wasn't hard at
No.
all.
Now this one, pay attention because now
Maybe
this
this
is
will be tricky.
be a little bit more.
C3 is a horizontal shrink of C1 by a factor of 1/2.
Woof.
Okay, so we're shrinking by a half,
Right.
and we're talking about the x values,
Right,
right?
right. The
And
x values are
remember
having to get
that
smaller.
Horizontal is talking about your x values, so what we do has to directly affect x.
Right.
So it's going to be on the inside, which means we got to
Right.
super secret oppositely flip it,
Right.
so that what we're really going to do
Is
is,
we're not working with 1/2, we're working with 2/1.
yes, so I'm going to multiply the inside of my function by 2.
Right.
And this is our function way of writing it. That's what we have up here.
That's right,
I
that's
already
right.
flipped the 1/2 and I made it 2.
And this is why function notation is so important, because now we're saying the function of 2x. That means everywhere we had an x in original,
We're gonna
every
put a 2x.
x now becomes 2x.
So where we had x cubed, now we've got 2x cubed.
Right,
Where we had negative 16x, now we've got negative 16 times 2x.
right, right.
Okay, because everywhere that we had x, we got to put 2x.
Word,
And we got to
word.
put it in parentheses because
That's right.
2x cubed
Is 2x times 2x times 2x.
and that's important. That can really be a deal breaker. Let me call this C3.
C3PO?
So C3.
Human cyborg relations?
Similar. It's a cousin of his, actually.
Okay.
8x cubed, and then 16
32x.
times 2, negative 32x.
Bamsies.
There we go. Ta-da.
Excellent.
Not too bad.
Excellent stuff.